Welcome, guys. We've been working on sequences and we just started beginning working on series in our previous video. Now we're going to work on arithmetic series in particular. Now you recall that a series is simply the sum of the sum of a certain number of terms in a sequence. Well, our goal here is that you will be able to find the sum of the first n terms of an arithmetic series, based on its related arithmetic sequence. Now, I'm going to give you a formula for this here in a moment, but I want to kind of give you an idea of how the formula works with a quick example. We're going to evaluate the series that you see right here, 10 plus 12 plus 14 and so on up to 22. Now, of course, knowing the exact 7 terms that are in this series, all we've got to do is the addition ourselves if we want to find what the sum of the series is. But there's a cleverer way of doing this that would help us say if this had 50 terms or 100 terms or 2,000 terms, because you wouldn't want to have to add up every single term if you had that many terms in a series. So pay attention to kind of the clever way I'm going to do this, and this is related to a story about a famous mathematician named Gauss. Now, I'm not going to tell the story here, I'll tell it in class, but you may notice that your book kind of alludes to that, so I want you to see it at some point. Kind of the clever way of evaluating an arithmetic series. All right, notice there is a common difference between terms, so it is arithmetic. Is if you will group the first and last term together, then the second term and the next to last term, the third term, the second from last term, and so forth. Let me do that. And what in the world is the point of that? Well, it turns out that every one of those terms that I paired together adds up to the same thing. 10 plus 22 is 32. 12 plus 20 is 32. 14 plus 18 is 32. And I just want to point out that we did have one term left over in the middle, didn't we? But that happens to be half of 32. Okay. Now when you start grouping like you do, what you're going to try to do is basically figure out how many pairs of terms you have that add up to 32. And in this case, you can say we have 3.5 terms that add up to 32. And so 3.5 pairs of terms that add up to 32. The sum, which we would represent by a capital S, of the first 7 terms of this series would be equal to 3.5, because you have 3.5 pairs, times 32. And 3.5 times 32, 96 plus 16 is 108. Now you can double check what 10 plus 12 plus 14 plus 16 plus 18 plus 20 plus 22 is, but it's going to end up adding up to 108. Does that make sense? How many pairs of 32s do you have? And that tells you basically what the sum of the arithmetic series is. Well, I'm about to give you a formula that does exactly what I just showed you every time. If you want to find the sum of the first n terms of an arithmetic series, then here is the formula that you're going to use. First of all, we'll represent the sum of the terms in a series with a capital S. Now, this is not the same thing as sigma, which also represents a sum, but very similar. And we're saying it's the sum of the first n terms. That subscript can be changed to indicate a definite number of terms. So if I wrote S of 10, it would mean 10 terms, or we were adding together and so forth. And the sum of the first n terms, well, I'm going to do this in parts. Remember the way we did this problem back here was we figured out what the first term was plus the last term to begin. And that's part of this formula. You add the first term with the last term. And then we figured out how many pairs of terms we would have that would add up to that same thing. Okay? And that just turned out to be the number of terms that there were, 7 divided by 2. There were 3.5 pairs, weren't they? This number was half of this number. Well, that's going to work the same way over here. If I want to know how many pairs of terms I have with this sum, I simply take the number of terms that are in the sequence or the series and I divide it by 2. N divided by 2 times the sum of the first term and the last term will give you the sum of the first n terms of an arithmetic series. Now there is another formula, but this is the one that I prefer to use. Still, I'll write the other formula for you because your book has it. And that formula would be that the sum of the first n terms is equal to n divided by 2 times twice the value of the first term plus n minus 1 times the common difference. And this formula would be kind of helpful to you if you didn't know what the last term in the sequence was. But I still prefer to use this one myself. It's a little bit more intuitive. All right, let me show you how to use it. We're going to find the sum of the first 10 terms of this arithmetic series. All right? Now, so we're going to use that formula, S of n equals n over 2 times the sum of the first terms and the last terms. So we'll write S of n equals, and well, you know what? Not S of n, S of 10, because we're finding the sum of the first 10 terms. And so that would equal n divided by 2, 10 divided by 2, times the sum of the first term, 2.5, and the last term. Okay, now, we don't know what the value of the 10th term is here, do we? So we're going to have to do a little bit of extra work using a general formula for the sequence related to this series. Now, the general formula here would be this. The nth term, or I should say the 10th term, would be equal to 2.5 plus 9 times negative 0.5. Okay, this is n minus 1. We're talking about 10 terms, so n minus 1 is 9, and this is the common difference, right? And that is equal to 2.5 minus 4.5, which is negative 2. So the 10th term in this sequence would be negative 2. And as soon as you're able to figure that out, well, now you've got enough information to be able to find the sum of those first 10 terms. Simplify, you've got 5 times 0.5. Those are going to add up to 2.5. All right? And actually, that should make a little bit of sense, right? Because if the 10th term is negative 2, wouldn't that cancel out with this positive 2? And then you'd have a negative 1.5 and a positive 1.5 that would cancel. Basically, every term after this 2.5 would cancel since they're opposites. Just a coincidence for this series. All right, another example. We're going to consider the series represented here, 29 plus 45 plus 61, all the way up to 365. And the first thing I'm going to try to get you to do is to find the number of terms in the series. And the second thing is, let's find the sum of the terms. All right, well, the number of terms. We've done this before. If you know the general formula for this sequence, then you can find out which term number 365 is. And that's what we need to do to begin. The nth term in this sequence would be equal to 29 plus n minus 1 times 16, since that's what the common difference is, right? Common difference is 16. And so if 365 is our nth term, what we're going to do is we're going to set 365 equal to that, 29 plus n minus 1 times 16. And then we'll do a little bit of algebra to figure out what the term number is whenever the term is equal to 365. All right, now the algebra that we're going to do, let's subtract 29 from both sides. 336 equals n minus 1 times 16. And rather than distributing this 16, it turns out, oh, this 16, same thing. It turns out to be a little bit easier if we go and divide both sides by 16 right now. 336 divided by 16 is 21. And then if you add 1 to both sides, you get n is equal to 22. There are 22 terms in this series. And now that we know that we're going to be finding the sum of the first 22 terms. And that's going to be equal to the number of terms divided by 2 times the sum of the first term and the last term. All right, now that's 11 times 394. Or 4,334. Make sense to you? Got one more example I want to try, and this was just going to have variables in it. It's basically the same thing that we did on the part one prior to this, actually, but with variables, like I said. Where this time I'm going to find the sum of the first 15 terms of this arithmetic series, which might not be obviously arithmetic to begin with, but I'll explain why it is. Well, we're going to have to go through the same process we've gone through before. We're finding the sum of the first 15 terms. And since we know there's 15 terms, we know we're going to multiply 15 over 2 times the first term, x plus 2y, plus the 15th term, but we don't know what the 15th term is yet. So we'll use our general formula in order to figure that out. I'll do the scratch word down here. The 15th term would be equal to x plus 2y, the first term, plus the common difference, which I'll tell you what that is in a moment, times n minus 1 times 14. Now, how do we find out what the common difference is? Well, we go up when we find the difference between any consecutive pair of terms. 3x minus x is 2x. 3y minus 2y is y. So the common difference is 2x plus y. You see the same thing here. 5x minus 3x is 2x. 4y minus 3y is y. That's our common difference. All right? So we'll place that common difference right here. And then we'll simplify. I'll see if you can follow a little mental math with me. We're going to have to distribute that 14, right? And then whatever we get, we'll have to add with this x plus 2y. Well, we'll have a 28x plus another x, so that'll make 29x. And then we'll have a 14y plus a 2y, that's plus 16y. So going back to the sum that we're trying to find, it's going to be 15 halves times x plus 2y plus the 15th term, 29x plus 16y, which is going to be 15 halves times 30x plus 18y. And then if you're clever and you notice you can do some canceling here, you can take half of 30 and half of 18 and then multiply by 15. You're going to end up with 225x plus 135y for the sum of those terms. That's how you find the sum of the terms in an arithmetic series, guys. See you next time. We'll do some more.